What's up? It's your old pal, Mr. Cook, and we are working on the last three problems of the Unit 6 group work for right triangle trigonometry. We already did one word problem. We focused on putting together the diagram first because that's a really important part of working through word problems. The rest of these are pretty easy, I think. Like this one might be a little bit difficult, but it basically uses the same ideas as number 17 here. So, just make sure you watch that video. A swimmer tried to swim due east across a river that is 734 feet across. If the swimmer ended up 384 feet north upstream, what's the direction or the bearing of the river's current? So I'm going to draw this out two different ways. So first, drawing the river. So somebody starts at one side of the river. They want to go across the river directly due east, and that's going to be 734 feet across. But the current pulls them so that they move. When they're swimming across, they go up here, and that's going to be north by 384 feet. So what we need to do is find the bearing that the swimmer goes from here to here. And that's actually pretty easy. All you got to do is just kind of remember some of the rules about bearings. First, when you start off in position, the first thing you want to draw is if it's going north or south. In this case, it's going north first, so north. And then if it's going east or west, and it says that it's going east, so it's going to go east this way. So the direction that the swimmer is going is still the same thing diagonally, but the angle that you get from the bearing is right over here. Be careful when you do problems like this because, on this one, if you didn't have the bearing angle correct, you might falsely assume that the angle that you're looking for is this one right over here, which it's not. It's actually this angle that gives you the bearing. And an easy way to kind of know from the diagram where your angle is going to be is by knowing this fact. The angle that you get in your bearings, one of the sides of the angles is always going to be the side that's going north or south. So you see how this one's going north or south like that? That means that the angle is going to be here. Notice that this angle doesn't have a side that goes north or south. It just goes east and west or diagonally. This is not going to be your bearing angle. It's going to be this one. So with that in mind, relative to this angle, the side across from it is 734, the distance that we go east. And then the side right next to it, the adjacent side, is going to be 384, the side that goes north. So we can find this angle really easily by using inverse trig. We can use the tangent ratio, so tangent inverse of the ratio of the opposite side over the adjacent side, and then just type it into your calculator. So that's how you get your angle on your bearing. So let's see what that's going to be. Tangent inverse of 734 over 384. And then we get right around about 62.38 degrees. All right, so now let's write it up as a bearing. So north or south, you go north, and then you get the angle measurement, 62.38 degrees, and then east or west, so you're going east, so you write east at the end, and that's your bearings. All right, now this problem asks us to interpret the bearings to put together a to put together a diagram that we can solve. So it says that a boat is traveling at a velocity of 25 miles per hour on a bearing of north 64 degrees east. After 7 hours, how far has it traveled due north? So the bearings are really easy to draw. You just start with this. You have a starting point, and then you go, with the first direction, so it goes north. So you just draw north, and then you go east after that. So then east is to the right in the cardinal directions, and you just draw an arrow going directly over to there. And your angle is going to be, whatever angle you have in between, so 64 degrees. There's your bearing angle. Now, the distance that you travel along this path, so this arrow represents the direction that the boat is traveling. So we can actually figure out the distance that the boat travels over that 7 hours by just using a really easy physics formula that you guys learned. And it goes something like this. The distance that you travel, if you know the velocity and the time, the distance is equal to velocity times time. So the velocity or the speed is going to be 25 miles per hour. The amount of time is 7 hours. Just make sure that those units match up. And then so 25 times 7 is going to give us the total distance that's traveled, which is 175 miles. So we just put 175 over here. And then it asks us to find how far that the boat has traveled directly due north. So whenever you travel diagonally on something, you're technically going both directions at once, north and east. So you can figure out how far north that you've traveled and how far east that you've traveled just by simply using trig. And like I said in class, this is kind of the precursor to vectors and understanding like component parts of forces, of velocities, and all that kind of stuff in physics. So bearings is sort of like a nice thing to know leading into that stuff, because you can break things apart, like a distance, in terms of two different directions, like north and east, just by using trig. So if I need to find just north, that's the adjacent side to this angle, and 175 is the hypotenuse, so adjacent and hypotenuse is cosine. So we do the cosine of 64 degrees is equal to the adjacent side, n, which is what we're solving for, over the hypotenuse, 175. So solving for this, I just multiply both sides by 175, and that means that to find the total distance traveled north, it's going to be equal to 175 times the cosine of 64 degrees. And if I type that into my calculator, I find an approximate distance, 175 cosine of 64. That's going to be 76.71, and then the units for this is miles. All right, so there's our answer for number 19. We have one last problem to work on, so one last word problem. A police helicopter is hovering at an altitude of 482 feet, so it's hovering, so that means that it's just straight up in the air, 482 feet. Watching a police officer pursue a suspect on foot. If the helicopter's angle of depression is 58, so that's different from angle of elevation, and we'll talk about that in a second, to the police officer, and 43-degree angle of depression to the suspect, how far apart are the officer and the suspect? So here's how the graph basically works out, or the diagram works out. You have your helicopter, and then you also have like a police officer that's running. After a suspect, so let's draw a suspect also. You guys got really long legs. Whatever, there's my suspect. All right, so whenever you see angle of depression, it means that your perspective is from like a higher position, like a helicopter, and then the angle looks down from that perspective. So you start off with the perspective of the helicopter. You draw a horizontal line out. It's real similar to how we drew the ground level for the angle of elevation. It's kind of like this, like how high up you are. That sets a bar, a horizontal line. And then your angle of depression points directly to whatever you're looking at. So like one angle of depression is going to go to the police officer. So that first angle that I draw is going to be a total distance or a total angle measurement of 58 degrees. So 58 degrees from here to here, okay? And that, creates a right triangle, obviously, to the police officer. And if I want to draw that separately as well, it might help out. So I'll probably do that in a second. But let me complete the diagram first that I have. So next we have an angle of depression of 43 degrees, so a smaller angle, and that's leading over to the suspect. So here's the suspect. There we go. And that angle of depression is going to be 43 degrees instead. So a smaller angle makes a longer distance away. Anyways, so if I want to draw these two triangles separately, it might be kind of helpful to figure out what I need to solve it all out. So I'm going to draw this triangle first over here. All right, there we go. I've got a 58-degree angle here. And then the altitude or the elevation of it is going to be 482 feet. So 482 is going to be the side that goes straight up and down like that. And just like that, I can use trig and solve for this side or this side if I need to. Let's, kind of look at the other stuff and figure out what we need to do first, though. So I'm going to draw the other triangle separately. So we've got another right triangle with a smaller angle measurement, but the same height, 482. And this is going to be a 43-degree angle. And once again, it's a right triangle, and I can solve for all the missing sides and the missing angles if I need to. What we're asked to do is find how far away the officer is from the suspect. So we're just looking for this distance here, from one to the next. So that's actually pretty easy to find because we can solve for this side length going from the helicopter all the way over to how far away the suspect is. That's this side, y. And then we can also solve for this segment right over here, the helicopter's distance to the horizontal distance away from the police officer. Let's call that x. That's going to be this side over here on the triangle. Now, once we solve for both of those lengths, if I kind of use those, the side length, y, if I were to take y and then subtract away this segment over here going from the police officer to this, so x, if I take y and subtract away x, I'm left with this distance, the distance that they are away from each other, d. So overall, what I'm going to do at the very end to find that distance between the two of them is take y, the longer side, and subtract away x, the shorter side. So let's solve for both of those first. So let's solve for x. Relative to 58 degrees, we have the opposite side. We need the adjacent side, so that's tangent. Tangent of 58 degrees equals the opposite side over the adjacent side. And then we just simply solve for the adjacent side by switching these two. So x is equal to 482 over tangent of 58. And then similarly, we're going to set up an equation and solve for y. So we've got the opposite side, and we need the adjacent side, so that's tangent again. So tangent of 43 degrees equals the opposite side over the adjacent side. And switch these two, so we get y is equal to 482 over the tangent of 43. All right, so now plug it into your calculator. 482 divided by the tangent of 58. And you get 301.19, so that's our x value. And then let's solve for the y value now, so we do 482 divided by the tangent of 43, and we get 516.88, that's in terms of feet. So 516, the larger side, 0.88. Minus 301.19, the smaller side. And let's find that approximate distance now. So 516.88 minus 301.19, and we get our answer, which is right around about 215.69 feet. So that's how far the officer and the suspect are from one another as they're running, and that completes the group work. So, if you need some help, combine the mornings or just ask for help from your teacher. You can even send them an email. And I don't know, I always thought that the hardest ones that you guys need to work on are like the word problems and the 30, 60, 90, 45, 45, 90 triangles. So if you've got all that stuff down, just don't overthink the problems, and good luck on your test. So that's it. Get an A, get a 100%. Okay, bye.